I think starting a rocket company is an unusual thing to do and pretty risky. But I'm a big believer in us becoming a space-sparing civilization and ultimately extending life beyond Earth. When I was in college, I tried to think, what are the really big problems that face the world, that which will most affect the future of humanity? And the three that I thought were the most important were the internet, transition to a sustainable energy economy, and the third was space exploration, in particular making life multiplanetary.
Pick it all up and start again. You've got a second chance, you could go home, escape it all, it's just irrelevant. It's just medicine. Just medicine. You could still be what you want to, what you said you were when I met you.
Yeah, I think it's important to have a future that is inspiring and appealing. I mean, I just think that there have to be reasons that you get up in the morning and you want to live. Like, why do you want to live? What's the point? What inspires you? What do you love about the future? And if we're not out there, if the future does not include being out there among the stars and being a multi-planet species, I find that it's incredibly depressing if that's not the future that we're going to have. I think the value of beauty and inspiration is very much underrated, no question. But I want to be clear, I'm not trying to be anyone's savior. I'm just trying to think about the future and not be sad.
We started in a garage with nothing, with even no tools. And it seems like a dream. When I come every day into the office, I see what we have now, and yeah, it's crazy. It's crazy. I met the other co-founder of the company, Raúl Verdú, in the university, and then we started working on a small rocket to try to reach 1 kilometer. We did it, and after that we said, okay, we go to do something bigger and bigger and bigger and bigger, and at the end we decided to create PLD Space and to start up. Well, technically developing a rocket from the technical point of view has different type of complicated disciplines. One is propulsion, so developing from the ground up an engine is tricky.
We are using all the parts to the limit of its capabilities. If they don't have the maximum properties that we can specify, like for example ultimate strength, wear rate, all that kind of parameters, we cannot comply with our task. So basically, if we fail in retaining the bolts, some connections could fail and that could lead to a catastrophic event. Typically in space you have to make sure that regarding the high vibrational environment you have to maintain the torque of your bolts. We saw that the typical aeronautical wire lock that is used through the head of the bolts is a difficult one to implement, especially in small parts with difficult access in the structure. So we thought that maybe there could be another option that we could use, and looking for it, we came across Nordlock. We've successfully used them in basically the whole bolted connections of the engine, and they work really well. So the torque is kept in our firing testing. So we haven't seen any loosening of the bolts, and we are quite happy with them.
Hi, my name is Corey Buckingham. I'm the trajectory engineer for the L-44 mission. There's a few reasons the Delta IV Heavy is the only vehicle that can launch the L-44 payload. Primarily, it's the payload fairing. The ULA payload fairing is 65 feet long and 5 meters in diameter. That's about 16.5 feet. And it provides sufficient payload volume capacity for the L-44 satellite. The performance capability is the combined performance of the first stage and the second stage. As you can clearly see, there are 3 boosters that provide over 2 million pounds of thrust to lift the vehicle off the pad. It's going to be a brilliant show. I can't wait to see it. Now talking about the second stage, the DCSS, the Delta Cryogenic Second Stage, is a very capable and highly performing second stage. A big contributor to the second stage performance is the extendable nozzle of the DCSS. We launched the mission with the nozzle in the stowed position, and then after booster jettison, the nozzle deployment system extends the nozzle to its full length. This very long nozzle is a huge performance increase because of the increase in ISP, specific impulse. ISP is how we measure the efficiency of a rocket engine. It is calculated as thrust divided by the flow rate of the propellants. A great way to think about ISP is related to your car. Your car's engine, the efficiency is measured in miles per gallon. It's a very similar concept with rocket engines, and the high ISP allowed for by the extendable nozzle of the RL-10 allows us to achieve the orbit of the L-44 payload. So if you're looking for someone to blame for the very early launch time, you can blame me. I'm the trajectory engineer, so I'm responsible for publishing the launch period. So how do we calculate the launch period? The time of launch is driven by the RAN, R-A-A-N, right ascension of the ascending node. The RAN is essentially a sun relative angle that the spacecraft requires us to achieve at spacecraft separation. So once we have the trajectory designed, the knob that we have to turn is the launch time. So we set the launch time to achieve the correct RAN. But then if you stop there, you have an instantaneous launch period. We want as long a launch period as possible to give us the best chances of launching on any given day. For L-44, we have a nearly 5-hour launch period. So how do we get there? Trajectory design incrementally steps out the trajectory until we reach the window open and window close time. That duration defines the launch period. Now these edge trajectories, they need to steer more and use more performance than the window optimal case in order to achieve the same orbit targets. We load specific guidance and navigation parameters depending on when we launch within the launch period so that robust guidance algorithms can get us to the correct orbit no matter when we launch within the launch period. This is just another factor of how the Delta IV Heavy can support the L-44 payload. Personally, I've been working on the L-44 mission for almost 4 years now, so I'm very excited to see all of our hard work come to fruition when it lifts off into the night sky. But more importantly, I'm looking forward to this vital asset to get on orbit and begin supporting the U.S. intelligence community, supporting national security space, and keeping Americans safe.
Three, two, one. Full duration.
It's been doing that the entire time? I think when they had a small leak with S&7, they just opened up the top vent.
Sort of flamethrower. Oh, there it went! Wow!
Right
That's spectacular.
That was at 4:58 on the dot.
Wow! And we got the pop.
Spectacular.
Did y'all hear the
Look at it
pop?
all go.
Look at that!
Wow. Was
Well,
that
at least it was worth the wait.
the
That was
top
the
bulkhead
top.
weld? Is that where
The
it went?
top
It looked like
popped.
the top blew off. Yeah.
Yeah.
Team pop.
Wow. Did the
That looks
lid
so cool.
go anywhere? Is the lid off?
Yeah, it looks like it's gone.
I think starting a rocket company is an unusual thing to do and pretty risky. But I'm a big believer in us becoming a space-sparing civilization and ultimately extending life beyond Earth. When I was in college, I